All right, so hello everyone. We're going to just start introducing ourselves real quick. So I am Jasmine Collins. A quick description of what I look like. I am a woman with red hair and green tips on my hair, and I'm wearing like a long pinstriped suit thing right now. I'm not actually sure what kind of clothing this is.
And I'm Ricky Gonzalez, a friendly Latino guy in a suit. And we are both Professor Shiri Asenkod's PhD students at Cornell.
Yes, so we are PhD students, like Ricky just said, here at Cornell University. So we're going to be giving a research talk for all of you guys. So a little bit different than the talks that you guys have had so far, though hopefully it'll still keep you nice and engaged. To begin with this, I'd like to ask a quick question. First, how many of you are familiar with applications like SeeingAI? Raise your hands, please, if you know what these are. Great. Okay. Quite a lot of us. In fact, most of us. So for those of us who aren't as familiar, these sorts of applications allow a blind or a low vision person to take a photo of their surroundings, and then they use computer vision to generate a description of that photo's contents. We can kind of consider this as perhaps one of the most widely used types of AR applications out there, which augment the physical world with accessible descriptions. Now, for example, that's what the beeping is. Okay. So for example, let's say that I took a picture of some completely random, totally not this, conference room and uploaded it to a scene description application. I might receive some kind of description like a crowd of people in chairs facing a stage. Now, this description provides me with some basic visual information about the room that I'm standing in. But if I'm in this room to give a presentation, I might want some additional details, like how many people are looking at their laptops right now instead of me. If I was trying to get to this room's exit, I might want some more information about the layout. In either of these cases, my original basic description is no longer enough to cover those needs. So to really optimize applications like this for users' needs, we first need to understand how blind and low vision people use them, what their use cases are for scene description applications. Now, some prior work has been done looking into this and trying to figure out how people use these sorts of scene description applications like VizWiz and Ira. But this work has really focused on human-powered applications, which are applications where a human, not an AI, is the one receiving the photo and augmenting it with a description. But the ways that people use human-powered applications can differ greatly from how they might use an AI-powered one. Past research has shown that a person's sense of trust in their tools, their perceptions of privacy while using them, and feelings of independence are very likely to differ when requesting support from an AI versus a human. Yet, despite these really clear human-powered and AI-powered differences, no one has explored how blind and low vision people use AI-powered scene description applications. Kind of a bit of a gap. So, as mentioned before, we're a university. And so to address this gap, we decided to conduct a user study. Big surprise, we're conducting research. Now, our user study that we conducted was guided by two research questions here on the screen. Number one, what are blind and low vision people's use cases for AI-powered scene description applications? And number two, how well are blind and low vision people's use cases or needs addressed in these use cases?
Okay, so now it's my turn to talk. So I will describe to you how we designed our study to address the research questions that Jasmine just shared with you. See, perfect. So we wanted to capture our participants' realistic use of an AI-powered description application, right? Like we want to know what people are actually doing with these tools and how well they work. This meant that we had to collect data from participants in diverse contexts, like at their work, public places, or their homes. But obviously, we can't just like follow people and see how they're using SeeingAI. It's not feasible. So in order to capture this data, we decided to conduct a diary study where we recruited 16 blind and low vision participants. We first held a scheduled video call with each one of them, and we introduced them to an AI-powered scene description application we developed. And then we had them tested at the beginning. Then they used the application for 2 weeks, and after the conclusion of the study, we interviewed them to gain direct insights about their experiences and all the information that we collected from their use. One big challenge with running our diary study was making an easy diary submission process. In a previous pilot study where we tried to run a similar study, we had participants use SeeingAI and fill out a diary entry each time they used it. However, in this iteration, we found that the process of submitting diary entries was difficult for participants. It had too many steps, which led to missing entries and inconsistent data. So just so you get a general idea, we had a template, and then participants had to send us emails with the information. And yes, a diary, you're supposed to reflect and write a little bit about what happened when you use the application, but this was too much of a burden for participants to consistently submit entries. To address those problems, we decided to connect the process of using the app with the process of submitting an entry. So we had to develop a custom application, unfortunately, how things happen usually with assistive tech. This allows us to directly collect data after every time that they use the application. The app first provided a visual description for the users and then brought them to a diary entry questionnaire where they filled it out. Finally, the app sent us all the data about the entry upon the submission and taking a photo. The data in each diary entry included a photo, a description of that photo, the participant's self-reported location, the information they wanted from the descriptions, scores for satisfaction and trust, and any additional comments. So here you can see the questions that we asked in the diary questionnaire, and they were designed to help us understand participants' use cases. The questions are, where were you when you took the photo? What information did you want to get from the description? How satisfied were you with the description? And how much do you trust this description, based on the content and the context? And then we also asked them to give us any additional comments, maybe tell us this is terrible, this didn't work well, or hey, I was surprised that this description was actually good. I didn't expect it to identify a transparent bag like the material plastic. So in addition to these responses, we also received the photo they took and its AI generated description. On the right side of the slide, we have an example photo of a tall apartment building with a description, a building with a glass front. At the end of our study, we had 316 diary entries to analyze, an average of 22 entries submitted by participant and 16 transcribed interviews. We coded all of these data with open qualitative codes and thematic analysis. For full details, please refer to the paper about this process.
Okay, so now we are going to dive into some of our findings here. Now, first, I'd like to highlight a critical takeaway that we pulled from the trust, satisfaction, and accuracy ratings that our application received, which are pictured in these histograms on the left side of the slide here. Now, out of a 7-point Likert scale for both trust and satisfaction, our participants rated the application on average 3.9 points for trust and 3.6 for satisfaction. For accuracy scores, we had research team members give each app description an individual accuracy score out of 3 points, which came to an overall application average accuracy of 1.96. Now, at a quick glance, these scores are all pretty mediocre. So you might think that this indicates that mediocre accuracy is tied to mediocre trust and satisfaction. But we didn't actually find that to necessarily be the case all the time. When we examined our data entry by entry and interviewed participants about their scoring process, we actually found a lot of instances where the trust and satisfaction scores directly contradicted the accuracy scores that we had given the descriptions. And in these cases, for these entries, accuracy didn't seem to matter all that much to participants' scoring process. And on this next slide, I'm going to share an example with you to show you what I mean. Now, pictured here on this slide, we have a photo of the back of a church pew. That one right there. Yeah, it's delayed. Oh, okay. We have a photo of the back of a church pew. There's a wooden bar across the back holding a paper pamphlet, a pen, and a Bible. Now, our application described this photo as a wood cabinet with a white device and a white device on it. It's a pretty bad description. It's horrible, in fact. It received our lowest accuracy score. But the participant who received this description rated it as a 4 out of 5 points for satisfaction and 3 out of 4 points for trust. Super high scores. And when we asked the participant why this was, she explained it was because the details that it was able to give were still enough for her to figure out what she had wanted to know, which was what was on the back of the pew. She stated, and I'll quote this here once the quote comes up, based on the color and the fact that there was that wood cabinet or shelf there, it kind of helps me deduce in my mind, like, oh, it probably means a white piece of paper, which she interpreted as a pamphlet of sermon notes. Now, examples like these showed us that our participants were used to pulling details that made sense to them, even out of nonsensical descriptions. So for cases like this, while accuracy could be important, as long as they got a couple of details that were related to their goals, it wasn't always the most important thing. Now, speaking of user goals, I'd now like to share with you guys some of the use cases that we found for AI-powered scene descriptions. And I'll start with two of the most common ones and then leave you with one uncommon but fascinating use case. So to begin with our top most common use cases, our very most popular use that we found for the app was identifying a specific subject. And this was when our participants were trying to find a particular object based on its features. So for example, one participant submitted this photo of a man's hand grabbing the sleeve of a long-sleeved white shirt hanging in a closet. And his query that he submitted with this photo was, what is the color of the shirt and does it have any stripes? Looking for features like colors or patterns that could help him identify the particular shirt that he was holding on to. This use case occurred in about 40% of our diary entry data set. Now, another top use case that we found was testing the application against a participant's current knowledge. So this was when participants were really trying to figure out how the application worked. So they would submit a photo that they already knew the contents of, already knew the answer to see how the app would respond. Now, this participant, for example, submitted a photo. You can turn your head if you guys would like to see it straight on, but it's a photo of a crosswalk at an intersection with red traffic lights hanging over empty streets. And the participants stated that they wanted to see what the app would pick up at an intersection and mentioned that they were testing landscape orientation with the photo. So essentially, they were throwing a new situation they'd never tried at the app before to see how it would react. This use case occurred in about 12% of our entries. Now, if you're interested, you can read our full paper to learn more about the other most common use cases that we had. But for now, I want to leave you guys with one of the more unique ones, which is using AI to win arguments with your friends. Now, let me set the stage for you on how this use case came up. So one of our participants was traveling with another blind and low vision friend of his to a conference during the course of the diary study. And at one point they were sitting in an airplane together and started discussing the view outside their window. And they absolutely could not agree on what was outside. So our participant decided to use the study application to get what he considered a fair and objective description of what was actually there. Now, this is an interesting example where our participant positioned the AI as a sort of arbiter for a visual dispute between himself and another blind or low vision person. And while this wasn't nearly as common as the use cases that we reported on our previous slides, it does show one of the many creative ways that our participants ended up utilizing the application and how they could get useful information in very unexpected ways from these AI-powered scene descriptions.
Considering all of this, where does this take us? What are the key takeaways of this study, and then how are we moving forward? Next slide, please, Ricky. First, our study uncovered some novel use cases for AI-powered systems that had not been identified for human-powered ones, such as the tester photos where users taught themselves about the AI capabilities. Modern AI algorithms are constantly undergoing rapid evolution. I think we are all very familiar with that. And to keep up with commercial applications that may receive constant behind-the-scene updates, it may be critical for users to keep testing these applications, and then we can also keep collecting data to learn about these use cases and actually give them what they need. Future applications should encourage this testing behavior, and perhaps by building in features that prompt the user to test the app again if a new update was pushed. The app design itself can be leveraged to encourage testing, keeping users informed about the AI capabilities and increasing transparency. Another important point we present is that accuracy does not equal usefulness for accessible scene descriptions. There's a huge focus right now in the AI research and development community on accuracy and making AI descriptions as accurate as possible. While accuracy is a good thing, when it comes to making description applications for BOB people, we found it's not always the most important thing. The user's knowledge is. A user may already know they are in a church, for example, and prefer information about the features of the objects around them, regardless of the app's accuracy in identifying the church setting. They can provide that. They are quite capable and knowledgeable. Future description applications should leverage user-in-the-loop mechanisms, allowing BOB people to share the context they already know about a photo's content and direct the application to provide the details they need the most.
All right, so these findings and guidelines are pretty useful for AI description systems in general right now, as well as the sorts of AR applications that are used currently, where you take a photo and then wait for a response. However, we believe that future versions of these applications can become much more interactive, providing their users with real-time and conversational support in a much more just engaging and interesting manner that also leverages a lot more of the XR technologies that are available to us now in the modern age. Now, we actually have a couple of projects going on in our lab currently where we are pulling these findings that we've gathered about AI-powered scene description in the real world, and we are placing them in things like virtual and mixed reality. So we're going to talk a little bit about those works to kind of cap off this little research talk for you guys. Now, first of all, first project we'll talk about, some of you may remember a project that was presented at last year's XR Access Symposium about taking a human-sided guide and placing them in virtual reality to offer navigation and visual interpretation support to a blind or low vision person. Well, that work came from our lab, and we've continued it by instead creating an AI-powered version of this guide for users to have. Now, this guide uses the newest AI description APIs that we have out there, specifically GPT-4, which we use to let the guide interpret and describe the scene. And its current abilities right now is that it can answer visual questions about the virtual reality scene it's in. It can also guide someone to particular objects around the scene, and it can provide accessibility modifications to that scene in the form of an audio beacon. So this is essentially a little sound effect that the guide can put on any object in the scene that the user requests them to, so that they can use the sound to guide themselves to that object instead of having the guide take them, if that's how they prefer to navigate in this virtual space. Now, if you're interested in this project, we actually have a demo available for it here at the symposium for you guys to try. We are on the second floor in classroom 215. Yes, 215. And so if you guys want to try it out, you can come up and check it out, and you'll be able to see how the guide can help navigate a small space full of these primitive 3D shapes, as well as how it responds to user input. Now, as a forewarning before you guys try it out, it might seem a little bit creepy if you can see the guide, because it's not animated yet or rigged for animation. So it'll just be this aggressively posing human avatar that you can see pictured on the screen, and it will glide inhumanly after you wherever you go and answer your questions without moving its lips. But the functionality, all those wonderful functions I just described are there.
Honestly, just think about it as your personal bouncer. And then we continuing with our second research project, we are deploying a new prototype to explore how BLB people are using visual interpretation with conversational AI in the real world. We want to understand why some people succeed with them and then others do not do so much. Similar to our VR study, this application will be powered by GPT, a variant of GPT-4, and it will be able to respond user questions about the images they take, but this time in the real world. The goal is to gather feedback from every interaction the user experiences with the visual interpretation agent, and then quantify how well these models meet BLB users' needs. So in summary, we present a study that investigated the uses of AI-powered scene description applications in the daily lives of BLB people and uncover novel use cases and challenges with these applications. This study is a small step towards bettering our understanding of how BLB people use AI-powered XR applications, and increasing this understanding could lead to new ways to combine the skills of AI tools and their human users, creating XR accessibility tools that empower BLB people as testers, directors, and active participants in the behaviors of their own tools. We also invite you to read our full paper and reach out if you have any questions or if you want us to send you our data. Thank you for listening.